So the whole point of this is understanding what it means for something to be a sequence when you're adding constants. So if v, w, x, y, z is an arithmetic sequence, we need to figure out which of these following must also be an arithmetic sequence. So if each of these, v, w, x, y, z are each separated by a constant, let's say, they're like 2, 4, 6, 8, 10 or something, each separated by 2. Let's evaluate the statements one by one. If we subtract 2 from each of these, all that does is reduce each of these by 2. They are still separated by that same constant value. So statement 1 is still definitely an arithmetic sequence. Statement 2, if we raise the first number in the sequence to consecutively greater powers, you're no longer actually keeping the same distance between each of the numbers. Let's just pretend that v equals 2, like we did here. So 2 squared is 4. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. So already, and then times another 2 powers, it's actually going to be even bigger. So we no longer have a steady constant between the values in our list. So raising them to exponents, which are themselves in an arithmetic sequence, does not maintain an arithmetic sequence. The last one, statement 3, multiplying each of these numbers while it does, just see what it ends up doing. We end up with 6, 12, 18, 24. So while the distance between the numbers here in our original sequence, the distance between each of them was 2, and here the distance between each of them is 6, the distance is still constant. It's not the same constant, but it's still separated. Each item in the series is still separated by a constant, and that's what defines an arithmetic sequence. So statement 3 is an arithmetic sequence. 1 and 3 are the correct answers. Choice C.